Hi, so we're back here at GDL Presents, where we interview unique and talented developers who are developing really compelling stuff. Today we have with us Mark Danks, who you might be familiar with his work at My Robot Nation. How's it going, Mark?
It's going well. Good to see you.
Cool, great. So, so you led development of My Robot Nation, which has this builder, which is this incredible app that uses WebGL to kind of create a rich experience. You want to talk a little bit about kind of, from a consumer perspective, how this whole thing works?
Sure. So what we were looking to do was really make it easy and accessible for people to get access to 3D printing. And we sort of were scratching our heads of what would be this awesome thing and really realized that little customizable robot sort of figurines would be pretty cool because each one would be totally unique. And so we thought about writing an app or a desktop app or something and realized that we could do it all in a browser. And it just seems to make the most sense to do that. So basically, you go to the browser. It runs full, WebGL, so it's all in 3D. But my background's all in video games, and so I sort of approached it of how do you make these complicated things really easy to understand, where it's sort of just drag and drop. You don't have to know anything about 3D graphics. You don't have to know how to model, but literally, it's an infinite, billions and billions of combinations of these different robot shapes that you can get, and they're all in full color. So you can put a hat on your robot. You can pick different body parts, and once you like it and got it all posed and ready to go. And you can go ahead and we'll 3D print it and send it to you in the mail.
Great. Yeah, it's really powerful and it's pretty rad to create your own robot and then get an actual physical version in a few weeks. So I wanted to talk a little bit about how this was constructed because it's really fantastic. So one of the things that has always been really interesting to me is seeing someone from the video game industry and bringing them into the web and kind of seeing what their development experience is like there. How did you kind of approach just getting into it, of kind of ascertaining what your development stack was going to be like and how you were actually going to construct with the new primitives available on the web platform?
Mm-hmm. Yeah, so the way I approached it first was really thinking about, there are two main aspects to the engine itself and sort of the interface. One of it is the 3D side of it, and so that's some really heavy JavaScript sitting in the background, and that's basically, it's a full-on game engine. We do collision detection, all kinds of stuff, and that luckily I have some experience on how to handle that, how to write all the shaders and that kind of thing.
Yeah.
So I was able to basically translate what for me used to be, hardcore C++ code into JavaScript, and was really, at the time I was kind of skeptical if this could work. How do you do a ray test against 10,000 triangles kind of stuff? And it just does. It works totally interactive, 60 frames a second, no problems at all. So that was pretty awesome for just getting the graphics side of it, the WebGL side. And then one thing that we did differently, I think, is really we're on the web. The web is all about interfaces. So rather than try to create the interface that you interact with, where you pick your attachments and your stamps and your robot pieces, rather than making that more 3D, which is really a pain in the neck to develop for, we actually do that all in normal HTML. Now, again, we're using things like jQuery and some pretty complex CSS, but the idea was we could bring the two together in a way that you really can't do on a lot of platforms. So that was a really nice thing. So I could spend all my 3D efforts and all my visualization in JavaScript and kind of treating it like a game engine. But then when we wanted to deal with how the people were going to actually interact with it and select all their stuff, we could just treat it as a normal web page and just have the two parts talk to each other.
Yeah. And was there any... So a lot of times, so a challenge for a lot of people with WebGL is that dealing with the actual GL primitives is pretty foreign. And so a lot of people just hop into using a library. Now, you luckily have a lot of experience, which makes working inside the the OpenGL ES2 kind of environment a bit more comfortable. Was there any third-party code that you kind of used in the construction of the application to kind of assist in probably not that, but other parts?
Yeah, for the actual 3D WebGL stuff, we wrote it all. And again, from my background, I'm a video game developer in the past, so I'm used to writing, on PlayStation 2 and 3 for Xbox, things like that. So it's pretty much, OpenGL, DirectX, all no problems. So for me, that was no problem dealing with shaders and how you handle all the actual, low-level vertex buffers and that. That was pretty easy. So for that, that's all completely ours. On the interface side, I mean, the one thing we are using is jQuery very heavily. So sort of all of the state transformations and animations and movement you see on that UI are all done that way. And so that was a pretty powerful thing, so we didn't have to reinvent all those wheels. And again, that's kind of what, when we were looking at it, how did we, we're looking at how to slice it of the web side versus the 3D side and really bringing the two together. So the main one was probably the jQuery library that we used.
So inside the application, I get to kind of choose the head and the torso and the legs of my robot. There's a bunch of different models. I can choose specific ones. I can randomize. I can then color them all. For these actual components, so these are all 3D models that. How did you basically take that from a 3D model that was designed in a modeling application and bring it out into something that you can now see in WebGL? Kind of what's the process for taking that there?
Yeah, so we had a bunch of modelers who worked with us, and they're standard game modelers or worked in special effects. So they're used to using programs like Maya and Max, sort of the high-end modeling packages. And in that case, we just exported a sort of a generic, a format called OBJ. It's kind of a lingua franca for the industry. And then I just wrote a converter that basically spit out all the stuff, WebGL ready to go, so I could just load it directly into vertex buffers and things like that. So for me, it's a fairly straightforward pipeline. The kind of interesting thing about how we have to do is, since we have the additional wrinkle of 3D printing, what we 3D print and what you interact with on the screen are actually different geometries. So on the screen, your robot's about 10,000 polygons. We print the robot at about 500,000. So we actually go through a pretty big translation step on the back end, where we literally recreate everything you've done on the screen and convert it to a print-ready model. So that was actually one of the bigger challenges of sort of how do you, what you'd see on the screen, if you print it, like nothing would be round, everything would be faceted and angular. You can't pull tricks with normals and shading in the real world, type stuff. So yeah, so we actually have this entire, translation process that occurs. It's kind of an interesting thing that when it's running actually in the browser, every frame, basically, I destroy the robot and recreate it from scratch. So every single texture, every single model, every single component, I rebuild from these instructions. And so every frame is literally redoing all of that. And then we spit out that same sort of instruction set. And that's the part then that we take these high-resolution 3D models, run it through another tool that reconstructs it and makes a printable model.
Wow. Wow, that's fantastic. So one question I just had, the OBJ format that you export the models as, is that sent down in a serialized format to the browser, which then interprets it and brings it up?
Yeah, no, we convert it to a JSON format. So that basically with that, I use it for two reasons. One is that we need to just load it directly into the WebGL vertex buffers and texture coordinates and normals and that kind of stuff. So that's just a straight load in the buffer, we're done. The other thing then is, since we do accurate collision tests against the models, I actually use that exact same data. It's basically massaged in a way that the WebGL can handle it, but then my collision code can handle it as well. So we can then go off and do all the collision on the exact same data. And there I have to get the normals, I have to get the UV coordinates. So I need all the data anyways. So rather than try to split it apart, send double the data down, I sort of have a little custom format that we made that just encapsulates it all in one type.
That's fantastic. So I'm curious, typically with applications like this, what people might run into is that the amount of data, like the models that they're sending down or everything else, it gets quite big. So on the web, you have this challenge of you're sending down all the bytes to the user that they're going to see, and it can be sizable. So kind of like, what are the challenges that you ran into there, and how did you solve performance, load time, things like that?
Yeah, so we sort of did it in two ways. Well, three maybe. The honest truth is we just went, we hope people have a fast net connection and just blow the data down the pipeline.
That's good.
But that being said, then what we did is we did a lot of optimization. So we do everything from welding of vertices, removing dead things. My JSON format is fairly compressed. So like if I'm sending a float down, I'll look at how many digits am I actually sending, and I'll strip it back and things like that. So we were able to get it from sort of a brain dead fprint float type mindset. We were usually able to reduce it down about a third from that size. Wow. So that was good. The other thing is we're not doing any tricks with the textures. They're just straight up PNGs we send through, but they are compressed. The other thing though that we do there is when you're interacting in the browser, the textures, the PNGs, the stamps are just 128 by 128. So
we can edit this in post.
Okay. Did we lose it?
Mark's back.
oh, oh. Was there, how much of that was lost?
Still there?
Yeah, I'm still here.
All right, let's go back to
We lost the last third of it.
Okay, I'll state again.
Okay.
Okay, so
Here, let me. I'll prompt you.
you asked the
again.
question.
Yeah. So, Mark, typically you run into a problem with applications like this that you're sending down these model data, you're sending down a lot of other things, and you have to deal with the fact that it adds up to quite a few bytes. Now, what kind of challenges did you run into in regard to like performance and load time, and how did you solve them?
Yeah, so there are sort of two main places where we're sending lots of data. One is the geometry itself, and in that one, since the sort of the internal data for collision and all that is the exact same as the rendering, we don't have to double that up. So that was one nice thing. Then I did a lot of optimizations on the data we sent through is in JSON format, and I actually really massage it. So the floating point numbers we use as smallest numbers as possible, and I was able to get it down from sort of a naive export out of my tool down about a third the size. Really looking at what, how much resolution in the UV coordinates do I actually need? Okay, if I don't need out to the millionth place, only send 2 digits kind of thing. Then the other thing is on the textures, those are actually 128 by 128 inside the engine. So they're pretty small thumbnails, basically. But then when we generate the print model on the back end, we actually use 1024 by 1024. So again, we're able to sort of trick it and only send through the data we need so you can see what it will look like. But then when we go to do the print model, we can use these really high resolution textures that are just awesome looking. The other thing that we do heavily is the entire engine is asynchronous loading. So we don't load anything until it's needed. And in fact, if you select a part, we don't even load it until it would appear on the robot. So for instance, if you select the top hat, you can immediately select it. We don't do any loading, we just wait. And then when you actually move over the model and we do, now you have to see the top hat, that's when we finally load it through.
I see. That's really smart. So yeah, this is really powerful. I'm wondering, when you were building it, was there any issues where you kind of like wish that you had some extra feature that was just not available in the browsers you were targeting, or any challenges like that?
Well, I wish WebGL was a little more ubiquitous.
Yes.
But that was just something that we decided early on that we needed to go for the best experience, and we go with it. Interestingly enough, I've actually made a change that's on some of our other apps now, where if you don't have WebGL, we actually render in Canvas 2D.
Oh.
So I can take, and the reason that, and it turned out to be really easy, I kind of wrote it in a weekend. And the reason was because I had all the collision data, which was the triangles. And so all I do is I just project it into the canvas as tries. I do a depth sort on all the triangles and you're set. So we actually have a fallback now. And so, I can actually run, not my Robot Nation, but some of our other apps, I can run on my iPhone and my iPad without a problem.
Oh, that's really cool.
So that was kind of cool to see. I think the general thing that we were seeing with it is just that we're so JavaScript heavy. And so it was over the development, and it was in development for 6 or 9 months kind of thing. It was really cool to see the browsers getting better and better on the JavaScript side, and literally we started telling by the end, we could tell the modelers, add more polygons, you can do it now. Whereas in the beginning, we were really restricted on what was possible there. A lot of the stuff that, I was doing some pretty weird optimizations on my math libraries, just trying to trick the browser into going fast.
Yeah.
And by the end, it was sort of good. I don't have to do that anymore. And so that was really a nice thing that, if you're doing a little one-off, div show hide kind of thing, you don't really care. But when you're doing something like this that's trying to run at 60 frames, suddenly your performance matters a lot.
Yeah, absolutely.
Yeah.
Well,
I think other things that I look at and look forward to are a lot more like binary support for data coming through the system. So that's the kind of thing where, if I had an easy way to encode basically, my JSON file as binary, that would be, pretty cool. A lot of the stuff there's a lot of people doing work I know on texture compression and like decompressing it in a shader.
Yep.
So stuff like that is, I've been watching pretty closely and kind of waiting for it to become a little more mainstream before putting it in. But, the new projects we're looking at are, even bigger than this one. So, we're trying to find ways that we can keep on pushing the content down.
Yeah.
I think definitely the our next big effort is really on how do we get the bandwidth requirements down, because once it's on the client, it seems to run pretty well, but getting there is the problem.
Yeah. I'm curious about kind of staying in tune with some of these conversations and like the features that are being standardized and being proposed. It's a little tricky sometimes to kind of monitor where these conversations are happening. How are you tracking, for instance, like texture compression or things like that?
Yeah, so thankfully it's really awesome. We got hooked in with the WebGL community pretty early. And we actually presented at the SIGGRAPH Birds of a Feather a couple of years ago, and that's sort of where we sort of burst on the scene and got introduced to everyone. So now it's everything from the mailing list, which are really helpful and really, really good. A lot of stuff happens there. Most of the people know I kind of lurk, but I read every single thing that goes through. And then I'm based in San Francisco, and so we have WebGL meetups once a month. So those are pretty good, where lots of presentations are given and talking about what's going on. And so I presented there. Actually, my company's hosting the next one on October 25th. So that kind of thing is a good place to meet people who are doing this and sort of find out what's going on. And also, it's really, all the people who are helping make WebGL real are really open and accessible and really easy to talk with. So
Absolutely.
That's been a really nice thing as well.
Awesome. Well, I encourage everyone to go check out My Robot Nation. And dig under the covers a little bit. It's a really well developed app and creates a great experience. One of the first great solid WebGL apps that's definitely not a demo, and it's real. Creates a real thing that you can hold even. So I encourage everyone to go check it out, see what's going on. And Mark, thank you very much for joining us and telling us about it.
So one other thing, if I can make a plug here.
Absolutely.
We've actually expanded a bit, and I'm actually in charge of a sort of another group called Cubify.com. And one of the things we're going to be releasing here in the next couple months is actually an SDK. So people can use this engine to make their own 3D printed models. So that's something which, keep an eye open for it, probably end of October, November timeframe. This code's going to be out and sort of fully supported.
Great. And say the name of it again.
It's Cubify.com.
Got it.
And if you go there, you'll see a bunch of other apps. In fact, just last week, we released an Android customization app. So you can make your own Android with the same techniques.
Cool. That's rad.
Yeah.
All right. Nice. Well, thanks again, Mark. This has been great.
Thank you so much.
All right. Cheers.